In this video, we are going to see DES data encryption standard detailed method, how in detail it is working. So first is, in the first step, the 64-bit plain text block is handed over to an initial permutation function. So first I'm going to just give an overview of the steps. After that, I will go in the detailed steps. So just you guys can take this also. Just take the diagram. Okay. So then initial permutation performed on the plain text. Next, initial permutation produces two halves of the permuted blocks, say left plain text and right plain text. Now each left and right plain text go through 16 round of encryption process. In the end, left plain text and right plain text are rejoined and final permutation is on the combined block. The result of this process produces a 64-bit text called cipher. So see, in this diagram, please note down this diagram. So first I'm giving the 64-bit plain text. Okay, then this will go through initial permutation. Now what is the initial permutation? In the initial permutation, some bits will be interchanged. That we will see in detail in the next step. Then this bits will be divided into two parts, which is left plain text and right plain text, each of size 32-bit. Okay, fine. Now these will go through 16 rounds. These are called Feastal rounds. After these 16 rounds are completed, it will go through a final permutation round, and then after final permutation round we will get the 64-bit cipher text. So here we will say in detail what is happening in the initial permutation. See, initial permutation happens before the first round. IP replaces the first bit of the original plain text block with the 58th original plain text and second bit with the 50th. Okay, so see, I will be having a plain text, 64-bit plain text. Here this is the 0th bit. If I am considering 64-bit 0 to 63, if I am numbering, so this position is 0th bit of original plain text. But initial permutation, what is happening? 58-bit means whatever 58-bit is, that bit value I am putting in 0th bit. Now in the second bit of the plain text, what I am doing, 50th bit position, whatever value is there I am putting here. This is the initial permutation. Then third bit will be replaced with the 42-bit, 42nd bit. Like this, these bits are just interchanged. Some positions. This is called initial permutation. Now after initial permutation, we will know what is the round function. We heard that there are 16 Feastal rounds. Initially we noticed that. Now what is that 16 Feastal rounds? That we will see how it is working. So how it is working. So in, earlier we have shown that how the bit is generated. The 48-bit key will be taken and 32-bit of right input, that is LPT and RPT. We have seen that LPT and RPT. So this RPT we will take right hand side and then 48-bit. Now here you have noticed that we have this 32-bit is the plain text, but the key is 48-bit. So how we can perform XOR? We cannot perform. So what we will do? We will go for the expansion. This expansion is called P box. P is permutation box. So 32-bit plain text, which is right side, will be converted into 48-bit. Okay. Now this 48-bit plain text will be XORed with the 48-bit key. We will get 48-bit output. XORing a 48-bit will give a 48-bit. Now after that, now again we have to convert this 48-bit into 32-bit. Now for converting this 48-bit to 32-bit, it will go through S boxes. There are 8 X boxes. Count 1, 2, 3, 4, 5, 6, 7, 8 X boxes. Each X box will take a 6-bit input. and it will generate a 4-bit output. So 4 8s are 32. Now we will get the 32 bit. Then after that it will go through a permutation. Then we will get the final output. Now in detail, if you want to see the expansion, how expansion is happening, we can see how 32 bit is converted into 48 bit. So 32, first 32, we are considering this 32 bit value. 32 is 32, then 0, 1, then 1, 2, 3, 4, 5. Now since I have to expand it, what I am doing, I am just repeating the bits. See here, 0 4 0 4 0 5 0 5, then 6 7 8 9, then again I am repeating this 8 and 9. In the similar way, I will repeat some bits so that the 32 bit can be expanded into 48 bit. Note down this table if you want. Now as we discussed the S boxes here. Now how S boxes are exactly working. See here we have discussed there are 8 X boxes. Now see how exactly S boxes are working. We'll see here. So 6-bit input I have got from S box, input for S box. Now how that will be converted into 4-bit, let's see. So this is the 6-bit input. Now I am combining the first bit and the last bit of the 6-bit input. So 0, 1 and the middle 4-bit together. Now we will see, since here this we will be having 4 rows. So 4 rows means for 4 rows I need 2 bits. 2 to the power 2 is 4. So 4 value I will get. So 0 0 0 1 1 0 1 1. So this is, and then here I will have 15 columns. So 15 columns and then 4 rows. Okay. Then see here 0 and 1. We will see the row 0 and 1. Then we have to find out this column 1 1 0 1. Here is the 1 1 0 1. Now in the row 0 1 column 1 1 1 0 1, the value is 1 0 0 1. So this is the 4-bit value for this 6-bit value 9. So in this way the S boxes are generating the 4-bit output. After S boxes have generated the 4-bit output, we will go through a state permutation again. The 32-bit output S boxes is subject to the state permutation. So in this state permutation, nothing we are doing, the same thing like initial permutation we did. First bit will be replaced with the 16th bit. Second bit will be replaced by 7th bit. Similarly, you can take note down here if you want. So this we are doing in this manner. That's it. So this is the end. Thank you.